Greetings, fellow mathematicians! We're going to take a look at another really good problem on finding the derivative f prime of x by using the limit definition. Now, this one's a good problem because the function contains a fraction, and fractions typically give Calculus 1 students a lot of difficulty. So we're going to take our time with this one and go through all the steps so that way you can understand what's really going on. All right, now we have our steps over here for calculating the derivative of a function, f prime of x, with the limit definition. Step 1, we're going to take our function and replace all x's with x plus h. And here, that's really simple because we only have a single x in the denominator. So first step, f of x plus h. That's really simple. We get 1 divided by x plus h. And there's nothing we can do with that, nothing to simplify, nothing to multiply out or expand, so we can move on to step 2. Now it's worth pointing out that in your limit definition of the derivative, much like the limit definition of the derivative at a point, you always get an indeterminate form. And the work here, the steps that you're going through, that's going to eliminate the indeterminate form. Now think for a second, our function is a fraction. Step 2 is a difference. You're going to be subtracting fractions. Your 4 standard algebraic tricks, one of them was using a common denominator. And that's what we'll be using here, which is most of the work. And that's going to occur now in step 2 when we take f of x plus h and subtract from that f of x. All right, let's write everything down. So we have the first term, f of x plus h. That's 1 over x plus h. And from that, we're going to be subtracting f of x, which is just 1 over x. All right, and as written, there's really nothing to cancel out or combine, but we're going to notice we're subtracting fractions with different denominators. We're going to combine them using a common denominator. And this is where many Calculus 1 students tend to maybe get stuck, especially if they try to plug everything in and simplify this all at once while manipulating fractions with a common denominator. We're going to split that into several easy steps, which should get you through this problem. All right, so to subtract these two fractions, let's use a least common denominator. And a common denominator, that's quite often the least common denominator, is just multiplying your two denominators here. So our LCD here is going to be x times x plus h. All right, and the work is just taking each fraction and multiplying numerator and denominator by the missing factors that would give you that LCD. Let's go ahead and write this out. All right, our first fraction is 1 over x plus h. And to get this LCD, we would need a missing factor of x in that denominator. So let's multiply the numerator and multiply the denominator by x. We're going to subtract 1 over x. And again, in order to get that LCD, we have a factor of x there. We're missing a factor of x plus h. So we're going to multiply the numerator and denominator by x plus h. All right, again, we're taking our time. Let's continue to do that. What we're going to notice here is we now have each fraction containing our desired LCD. Now, we're going to subtract the numerators, but because we have in the second fraction here two terms, x plus h, with a subtraction sign, you can go ahead and use your most important tip here of using parentheses right around that numerator x plus h, because again, we're going to be subtracting those fractions. All right, let's go ahead and first write down the fraction here with a common denominator. All right, your common denominator is going to be x times x plus h. And now, subtracting your numerators, you're going to have 1 times x, just x, minus, and this is where, again, use parentheses around those two terms. We're going to have minus x plus h. All right, now before we move on, I want to mention a few things. First, a very common mistake is students trying to cancel out x plus h here. Now, there's an x plus h in the numerator, there's an x plus h in the denominator, but be careful, x plus h in the numerator is not a factor. What's preventing that is the minus sign. So this x plus h and that one, they do not cancel. If this minus sign were a multiplication sign, then in the numerator, x plus h would be a factor, and you could cancel it out. All right, so just be careful of that. Another thing which I want to point out, you can typically keep your denominators factored here. So don't worry about distributing or multiplying out x times x plus h. Let me mention that as a tip. Which you want to keep in mind, but sometimes you want to go against this. The tip here, we're going to keep the denominator factored. And that just makes basically the rest of the work a little bit simpler and easier to write. All right, again, we are taking our time. Now, if we go ahead and distribute that minus sign, we're going to have x minus h, and then all over, keeping the denominator factored, x times x plus h. And if you go ahead and simplify this step by step, you can subtract out the x's there, and what you're left with in that numerator is minus h divided by x times x plus h. And that is most of the work for this problem. All right, now we're going to move on to step 3, which is taking this difference and dividing by h. Now, we're going to use the equivalent version because our function is a fraction, and we don't want to have fractions within fractions. So instead of, in step 3, dividing by h, it's equivalent to multiply by its reciprocal, 1 over h. So let's go ahead and write that. We're going to have f of x plus h minus f of x. And we're going to write in the general version here an h in the denominator, but when we actually calculate that, I'm going to multiply by 1 over h. And what we're multiplying by 1 over h was f of x plus h minus f of x. That's what we just worked through and simplified here, that fraction, which was negative h over x times x plus h. And now, it's a little more obvious that your factors of h cancel out. Now again, I want to point something else out. There was a check here in step 2, which is that all terms that are left should contain an h. And if you take a look at your answer here for step 2, the numerator does contain a factor of h. So at this step, it does pass the consistency check. That fraction does contain a factor of h in the numerator. And now, when we equivalently multiply by the reciprocal, multiplying by 1 over h, you can see those now cancel out, and what we are left with at the end of step 3 is negative 1 Remember, when factors cancel, you're left with 1 over x times x plus h. And now we go to our last step, taking a limit as h goes to 0. If you've gone through all the work here and fully simplified this, you should find that the indeterminate form cancels out, and that occurs right here. The indeterminate form, buried in the limit definition, 0 over 0, that cancels out here, and now we can evaluate the limit of this basically by plugging in h as 0. So if we write this down, we get the derivative f prime of x as the limit as h approaches 0 of this. Negative 1 divided by x times x plus h. And there, we're just going to plug in h equal to 0 because there is no more indeterminate form. So we can evaluate this limit by plugging in. And I'm going to write this out. What we get directly is negative 1 in the numerator. The denominator has a factor of x outside the parentheses. And then in the parentheses, x plus 0, we can just write that as x. And if you go ahead and combine there, that's x times x. We get in our denominator x squared. So our derivative here, f prime of x, comes out to negative 1 divided by x squared. And let's just go ahead and write this down like we've been doing from the previous problems. Our function f of x is 1 over x, and the derivative f prime of x, we got that as negative 1 over x squared. And you can have that negative either in the numerator or you can pull it out front. Both of those are standard ways to write this fraction. And there we go. Now here, the focus was on taking our time to really understand all the steps and bit of work here, which was basically using a common denominator. Take your time with that, like we did here, and you'll be able to get through a limit definition of the derivative question on your own. Hope you enjoyed the video. Hope you're learning a lot. If you are, support the channel, like and subscribe.